Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 10 of lesson number 10, Gravitation. So most probably we are just left with two parts in the lesson. One is Archimedes' principle and the other one is relative density. So don't worry, I'll be completing that in this part, that is part 10. We will be discussing about the Archimedes principle, which is again a very important question, and then we have relative density as well to discuss. So we'll be doing that as well. But before I start with it, I want each one of you to be thorough with the previous part that we have studied, right? So I want each one of you to quickly go through the notes that you had, starting from part 1. You need to revise each and everything. Everyone, please be quick with your revision, and now your revision is going to be different. You're not going to read it from the notes that you have written. You're going to just let yourself know what are the different topics that you have studied and what do they exactly mean. Like for example, if you are revising for universal law of constant, like how to calculate that. So you have to come up with the derivation. You can write it by yourself, not by looking in your book, and then you can cross check whether you're doing it correctly or not. So now you have to change the way of revision that you did for part 2, part 3. That was okay. Like if you were going through your notes in that part, till part 6 it was okay. But now you have to do this kind of revision. Okay, so I hope every one of you are starting with the revision. Be quick with it, everyone. So like we have started the lesson by discussing about gravitation and in detail, where we actually studied about how Newton came up with the concept of gravitation, right? So I want you all to please explain it to yourself. I don't want you all to like go through it. You have to explain the concept of gravitation to yourself. Okay? After this, we discussed on this activity 10.1. So I just want each one of you to please go through it. Then we discussed on the universal law of gravitation, and I hope like you all have understood how you have to revise it now, right? So please do the same way that I told you. After this, we discussed about like Sir Isaac Newton, like who exactly he was, where he was born, and what he was interested in, how he did his studies, and then how he did his research work. Everything has been given, right? Then we had this example where we saw like on the basis of the like given information, how can we calculate the value of the force, right? How can we calculate force, right? Then we discussed on the importance of universal law of gravitation. So I just want you all to please go through it as well. Then we discussed on free fall, where the proper explanation has been given over here for free fall. So please go through this as well, everyone. Now, as I told you that you need to explain it to yourself, whatever has been given, right? So please go through it. Then after free fall, we like even saw how like we can come up with the equation for acceleration due to gravity, right? Then we discussed on like how can we calculate the value of G. So I want you all to please go through it as well. Now you have to do it by yourself and like check whether you are aware of it or not. I hope you all are doing it. Then after this we discussed on like motion of objects under the influence of gravitational force of earth, and the proper explanation for this, like what will be the motion of object under the influence of gravitational force, is being explained over here, and that has been explained via through three different equations, right? So I want you all to please go through it as well. I hope you all are going through this example. Now, like You know that in the exercise question we have like many examples, which like many questions on the basis of numerical that we need to solve, right? So make sure you know them as well. So sorry. After this we had one more example, so I just want you all to please go through it as well. You need to like check how the formulas are being used, how are they applied and everything. Okay. After this we discussed on mass and weight. So please go through the points that have been given for mass, and then we will discuss about weight as well. Then we discussed on weight, so I want each one of you to please go through it as well. Then over here we have the SI unit and like what exactly weight does. So everything has been given over here. I want you all to please go through it quickly. After that we discussed on like the weight of an object on moon, what exactly it will be. So I just want you all to please go through this slide as well, because like here you have the derivation for it, so you should be knowing it and you should be clear with it as well. Then we had this example that has been given. After this we had one more example on weight, so please go through it as well everyone. Then we discussed on thrust and pressure. So I want you all to please go through it as well. So after this thrust and pressure, like there were two different situations which were given, right? Here we had situation 1 and here we had situation 2 that has been given. Okay, so I just want you all to please go through it as well, because this is again very important. You understanding it properly is very important, right? So please go through this slide as well, everyone, because both the situations are explaining us with respect to thrust and pressure. And once you like go through it, see, I am explaining you, you will understand it, but that will be like for okay, like that is you will understand it 50%. 50% you'll understand it when you like have your own efforts into it by going through it, and like that way you'll understand it more clearly. Okay, okay. So over here we have the like formula for pressure that has been given, which is equal to thrust upon area, right? And we have the SI unit as well, which has been given. So please go through this as well. Okay, and then we will start with like we will discuss the further part that we have. But you being clear with thrust and pressure is very important. Okay. After this, we had example 10.6 again, where we calculated the dimensions and all of dimension of the wooden block, right? So I even want you all to please go through this slide and like check how exactly they have like used the given information, then they knew what to find out, and then they have the formula for pressure that they have put in, right? So everything has been done systematically, right? So you also had to do it the same way, like if you get this type of question further. Okay. Then after this, like the solution given is the same. We discussed about pressure and fluid. So I want you all to please go through it as well about pressure and fluid. And after this, after discussing pressure and fluid, we'll discuss on like we discussed on buoyancy as well, right? So I want each one of you to please go through it again. Then after buoyancy, we had this activity 10.4 that we discussed. So I want you all to please go through this activity again, and whatever question marks have been given, you need to ensure that you are understanding it well. You are answering them as well. Okay? So here is the explanation for that activity, right? I want you all to please go through it. Then we discussed on like why the objects float or sink when placed on the surface of water, right? So I want you all to please go through it because like over here we had one activity and then we had one more part, right? Then we discussed on this activity 10.6. Now we need to study Archimedes' principle. So we will be studying that with respect to this activity 10.7. See, take a piece of stone and tie it to one end of a rubber string or a spring balance. What will you do? You will take a piece of stone and you will tie that to one end of a rubber string or a spring balance. Then suspend the stone by holding the balance or the string as shown in figure 10.6a. What are we going to do? We are going to suspend the stone by holding the balance or the string, like the way as you can see that has been holded, right? Then note the elongation of the string or the reading on the spring balance due to the weight of the stone. What are you going to note? The how much the string is getting elongated, and we need to see the reading on the spring balance as well due to the weight of the stone. And now slowly dip the stone in the water in a container as shown in figure 10.6b. So you can say 10.6a, like the string has been tied to the stone, right? So observe the elongation of the rubber string. Now this string is a rubber string, so we know it is going to elongate. So we need to just measure how much it is elongating, how much it is elongated. Okay. So elongation of the rubber string due to the weight of piece of stone suspended from it in air. And this 10.6b is elongation decreases as the stone is immersed in water. So when it is outside the water in air, the elongation will be more as compared to when the stone is in water. Okay. So you will find that the elongation of the string or the reading of the balance decreases as the stone is gradually lowered in the water. So what will happen? The elongation of the string will decrease as the stone is gradually lowered in water. However, no further changes observed once the stone gets fully immersed in the water. Like once we completely immerse the stone inside the water, there will be no change in the string. So what do you infer from the decrease in extension of the string or the reading of the spring balance? What can you say from this? We know that the elongation produced in the string or the spring balance, that is due to the weight of the stone. Why that elongation is taking or is happening? Because of the weight of the stone that has been tied to it. Okay. So since the extension decreases once the stone is lowered in water. Okay. Now once we take that stone and immerse that in water, what happens? The extension decreases, right? So it means that some force act on the stone in the upward direction. So you are already aware of thrust and pressure, right? We have already discussed about that. We even discussed about buoyancy, right? So what is happening? There is an upward, there's a force acting on the stone in the upward direction. So as a result, the net force on the string decreases and the elongation also decreases. Why? What is happening? Because the net force on the string is decreasing. That is the reason that the elongation is also decreasing in the string that has been like immersed in water. Okay. So as discussed earlier, their upward force exerted by water is known as the force of buoyancy. Okay, what is this upward force exerted by water called as? It is known as the force of buoyancy. Now we have already studied about buoyancy, right? So now the question is, what is the magnitude of the buoyant force experienced by a body? Is it the same in all the fluids for a given body, or do all the bodies in a given fluid experience the same buoyant force? What do you think? So the answer to this all these three questions is contained in Archimedes' principle. So what does Archimedes' principle states? When a body is immersed fully or partially in a fluid, it experiences an upward force which will be equal to the weight of the fluid displaced by it. So this is what Archimedes' principle is. Any object, when it has been immersed in water, there will be an upward force which is going to act on that, and that upward force will be equal to weight of the fluid displaced by it. Okay, so now you can explain why a further decrease in the elongation of the string was not observed in activity 10.7 as the stone was fully immersed in water, right? It is all because of the upward force which is like equal to the weight of the fluid. Okay, I hope every one of you are writing about the Archimedes principle. I hope every one of you are writing about this. Now see, like we need to discuss like who Archimedes was, right? See, Archimedes, he was a Greek scientist and he discovered the principle subsequently named after him after noticing that the water in a bath, like water in the bathtub, overflowed when he stepped on into it. Now, when you do that, it is going to happen with you as well, right? So he was noticing that and he came up with the principle and he stated that when a body is immersed fully or partially in a fluid, it experiences an upward force, and that upward force will be equal to the weight of the fluid displaced by it. Okay, so he ran through the street shouting eureka, which means I have got it. So once he knew the reason, once he was aware about the Archimedes principle, he ran through the streets and he shouted eureka, eureka, which means I have got it. So this knowledge helped them to determine the purity of gold in the crown made for the king. So he was working for king because of the principle that he came up with. And his work in the field of geometry and mechanics made him famous because his understanding of levers, pulleys, wheels and exile helped the Greek army in its war with Roman army. So he was, because he was a Greek scientist, he was helping Greek army during that time. Okay, so now we have like one more concept to discuss, that is relative density. So we already know the formula for density, that is like mass upon volume, right? So as you know, the density of a substance is defined as mass of a unit volume. How do we define it as? Mass of a unit volume. So the unit of density is kilogram per meter cube, right? Kg per meter cube. And the density of given substance under specified condition remains the same. So density of the substance is going to remain the same, and therefore the density of substance is one of its characteristic properties which is going to be different for different substances. It is not going to be same for all the substances. Density is going to be different for different substances. For example, the density of gold is 19,300 kilogram cubic meter, right, per cubic meter, while that of water it is 1000 kg per cubic meter. Okay, so the density of a given sample of a substance can help us to determine its purity. What it can help us with? It can help us to determine its purity, and if it is it is often convenient to express the density of a substance in comparison with that of water. Okay, so here we have the formula for relative density that has been given. It is the ratio of the density to that of water. So whatever substance that we have, relative density will be equal to density of the substance upon density of water. Okay, and since the relative density is a ratio of similar quantities, relative density has no unit. You need to know this, that relative density has no unit. Okay, so now we have like many important points on this like screen. I want each one of you to please go through it properly. You have to write all the important points and you need to mention that relative density is going to have no unit. Okay. After this, now we have an example with respect to relative density. So see, relative density of silver is 10.8. The density of the water is 10 raised to 3 kg per meter cube. What is the density of silver in SI unit? So now the relative density for water that silver that they have given is 10.8. We know the formula for relative density is density of substance upon density of water, and here the density of the substance is silver, right? Density of silver upon density of water. So it's equal to, like, because we know the density of silver that has been given, so what we will do is equal to density of silver, like density of silver into density of water, and we get the answer as 10.8 into 10 raised to 3 kg per meter cube. Okay. So now we have the summary discussion that we will be doing in the next class. I'm not going to do that now. Okay. So along with this summary, we will be even discussing on 22 exercise questions. I'm going to show you all the questions one by one, and I want each one of you to be clear with it. Okay. So please go through the questions thoroughly, everyone. I hope you all are going through this exercise questions. So this is the last question that we will be discussing at the end of the lesson, and I hope like whatever we discussed with respect to relative density and Archimedes principle, you all are very much clear with it. Now the rest of the part, like the summary and the exercise part, I will be starting with that in the next part, but make sure you all are revising each and everything and you are clear with each and every concept that we have studied so far. Okay, so I'll end this part over here. Thank you everyone.